Alright, I'm going to try to let this go kind of quick so I don't bore you with this. But this is a space tether that broke 1996. It's 20 years ago. I have a theory that light is spinning disks that are coming from the sun that are just loose electrons, and they spin and they create these spinning disks, and we have photographed those in our experiments in the lab. Well, not really a lab, but it is, these are the particles that we have photographed. Now, that is what I am saying. This is a torus, and this is what's called inductive, what am I calling it? Well, it's inductive capacitance. It's capacitive reactance and inductive reactance, and they work flip-flop in a torus. And it's all figured out somewhere. I have it written down, but it's pretty obvious what's going on in my mind, is in my theory. So that's what I'm saying. This is a positive and negative, and it's flip-flopping, and the toroidal neck creates what's called a choke. The choke creates up to 10 times the applied voltage. It blows up like a balloon, actually, exactly identical like a balloon, and then it lets itself back out. So it's capacitance sucks up a bunch of stuff, and inductive reactance forces it to stop, and then you know, it discharges backwards. That's how it works. Everybody knows that in electronics. Anyway, these are other shots we have. Those are the electrons in the trail. This is what we made a Venturi over here that accelerates the particles. And the ancients knew all about this. These are coming out of the chaos of the Venturi. That is a single disk with no you know, molestation, so to speak of. This is an accelerated disk, and that is the Venturi, and as it approaches the Venturi, it elongates because it's being accelerated. And then as it goes through the Venturi, which is a restriction, and there is no other option other than to accelerate, and then it atomizes in chaos, and then it starts to decay right here back into its, you know, when I say decay, it starts to decelerate. Anyway, and I have pictures of all that too. So this is that's what happens. Now, this is the pattern of light, and it screws. It literally screws, and we have pictures of that too. So here we're going through the accelerator, and you can see it screwing through the accelerator. The accelerator, it's hard to explain this, but as it screws through, some go here, some go here, some go here. Depends on where it hits. If it hits there, it's okay. If it comes around and hits this way, it goes that way. If it hits right in the middle, it shows up in the middle. That's why it's so bright. So anyway, that's how that works. Now, here's something very interesting. These are the discs that we've photographed. And the disc hit another disc, and this little disc came off the disc. And you see all these little tiny bumps on there? I'll show you better shots of that. But there's little tiny bumps and all this stuff, and I believe those are the particles. Alright, now let's take a look at this. You see all the bop? Here, let me get it a little closer, maybe you can see better. You see that? You see the different colors, first of all, and you see the different density of this compared to this, and compared to this, and compared to this one. What it is you see the dots. I believe this is a stroboscopic effect of picking up the electrons in their rotational orbits, you know, and this is the same electron, but it's gone to all these places in a stroboscopic effect within this one picture. So we're not picking up thousands and billions of electrons, we're picking up one in a big fluffy balloon, but we're seeing the trails. It's still going as we're taking the picture. That's what I'm saying. And the density of these is the the spin. The spin is a frequency. Alright, so the faster it spins, the denser it is, because it has more angular momentum, and it's more heavy. And the only thing that there is, literally, is energy equals mass. Mass equals how fast the particle. They're all the same particles, same weight, starting weight, 0.00055 atomic mass units, supposedly. They're spinning like crazy. Some of them spinning faster than others. The ones spinning faster than others hit harder. That's all it is. Alright, now, let's go to the next one here. All right, this is what we think is the electron, and it's bip, 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 and you see it's drifting to the left. That means it's a right-hand spin, so it doesn't quite get to the same place fast enough. You see how it's compressing after it's been elongated? These are each particles, in my opinion, and this is all one picture of lengths of the same, again, the same electron. All right, now this is looking down into the light, and here you see the pattern of light, and there's the particle, and that's the pattern, and you're going to see that in space. Now, so again, now we were looking at one particle spinning for a long distance of time, and then of course there's a particle again. What have we got here? There they are. There they are. Okay, I got a lot of pictures of this stuff, but let's go back to where we were before. Hold on a second now. Alright, so let's go and watch this tether incident from the beginning, and you've seen what we think light is.
In the call reporting that the crew can see the tether and see the satellite. It's beautiful.
He won't know what to say shortly. There they are. Just coming into sunlight.
This view showing
he has no clue what to
the
say.
Satellite. Again, just moving into sunrise.
There it is, just moving to the sunrise. You can't get him out of the picture.
81 nautical miles now from Columbia.
He's trying to focus in and out, you know, and you'll notice, you could be able to see, sometimes he'll get back away and go back in, but he just can't, there's no way he can get him out of there. And they're being quiet because they have no clue what to say. I mean, look at that. And there appears to be no limit to the speed of fast or slow. And they just are clueless as to what to say. Now listen to hear what happens.
Just getting the image.
Franklin, we see a long line, a couple of star-like things, and a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated by the sun at such low angle. So there's a lot of stray light, and it's getting washed out quickly, but Claude is trying to do a quick, good job here adjusting the cameras.
Alright, that's the key. It's going to get washed out quickly because they made a big mistake doing this because they showing what sun. I mean, if they don't, it appears nobody wants to know anything about reality. So, to me, they made a mistake doing this because they just showed reality. And it only happens when you can see at the precise angle of the sun. So if they did this during the day or they did this during the night, you would never have any idea about this. But this is exactly what Rod and I are picking up on our experiments. So that's all I can say. And I wish somebody would look into this, but I can see there is no speed limit to light. And we know that. Our tests showed that. We know that that it slows down in water or any different kind of media. You know that I just showed you that it speeds up in our accelerator in the Venturi. So that's all there is to it. Somebody should look at it. That's my point. I'm not saying that's all the way up down the story. But wait till you see what light does. Keep your eye on this because we know, or I've seen in the pictures that it oscillates. I know that it's an oscillator. You could see it in that single little bit pieces. Now listen to this and watch what happens.
Copy that.
That description by the crew, this is the tether in the satellite.
Look at that.
The satellite with approximately 12 miles of tether still attached to it. Columbia and the satellite now just passing over the west coast of northern Africa.
Look at it.
The two spacecraft now 90 nautical miles apart.
Now they'll start pulsating. You'll be able to see them as they try to dig in and out.
Controllers for the satellite did have communications
Right,
with it during the close pass. between Columbia and the satellite.
Watch him jiggle. Look at him. There's pulsation going on now that they're picking up. They couldn't see before. He's trying to dig in. Now watch here. Watch over here. Watch this one.
Visible.
Watch this.
And how wide does that tether
Bam.
be? It seems to resemble a
Look at that.
much wider strand than we'd expect. Can you describe which way the satellite is visible on that strand?
You see some of them swinging faster, faster, faster. Some of them are just bubbly, barely moving. This is extraordinarily clear what these are, and these are light particles. There can be no other explanation, although, you know, I mean, that's usually, you know, I'm reasonable. If I'm wrong, but I don't know. Somebody else has to prove that to me. Now, again, no size, no speed limit, and they do exactly, look, now look at this. These are, the whole sky is filled with these if they get it in the right focus, and he's trying to drift in and out to try to get him out of the picture. Watch.
Satellite now.
He ends up trying to make it so dark that he can't see any of them. This is kind of funny, actually.
You're full extent of the tether.
They're trying to
I
get.
tried to adjust the focus, but I can't get better than that.
Okay, Claude. Thank you.
I'm going to zoom in now.
See, Claude can't get. See, they want to try to get him out. They can't. There's nothing they can do to get him out. So they finally give up.